So in this scenario guys, if I want to use internet, what I need to do, I need to connect this router to internet router. Let's say this is my router 1 R1, right? So simply I can purchase public IP address from any ISP, right? Like from Tata, I can purchase one public IP address, and then I can connect my router to internet router like this. Internet like this. So when you will purchase public IP address, your ISP is also going to provide you one DNS server IP address, right? So that is DNS in your service provider network. Like your ISP is Tata. So from Tata you have purchased public IP address. So Tata is going to provide you the IP address of DNS server. You don't need to set up DNS server in your network. Or even let's say you have multiple application in your network guys, then you can set up your own DNS server as well for internal translation, for internal domain to IP translation. And for external translation, ISP is going to provide you one DNS server IP address. Then here I have one DHCP server. So what is the role of DHCP server here? DHCP server. So yes, so that my client can get IP address, submit mask, default gateway IP address, right? DNS server IP address. These all addresses from DHCP server automatically. Correct? And in last class, we did practical of DHCP, DNS, HTTP. Correct? Today we will see the FTP practical, TFTP practical, and some other application layer protocols practical like Telnet, SSH, and we have many more protocols. Okay. So guys, see this PDF OSI model. So why we need OSI model? To connect, to make communication possible between different vendor devices. Yes or no? Before OSI model, different vendor devices was not able to communicate with each other. Means Dell devices can communicate with Dell devices only. Dell device cannot communicate with HP device. I'm talking about before OSI model. But nowadays, the process, the protocol to make communication between two or more networking devices same is common. So this is why we are able to communicate with any other vendor devices. Right? So after OSI model, now different vendor devices can communicate with each other. So as I told you, it acts as a blueprint. Hope these points are clear to you. Then guys, in OSI model, we have 7 layer application layer. So what is the use of application layer? Application layer, it provide user interface. How you are going to interact with service or server. Let's say Google server, you want to access Google server. So through application layer, you can interact with your Google server, right? Then guys, what is the use of presentation layer in OSI model? Encryption, decryption, compression, decompression, right? Session layer, creating session, maintaining session, and terminating session. Then transport layer. So as I told you, as a network engineer, you need to master transport layer, network layer, and data link layer, right? And physical layer as well. So guys, see, yesterday we discussed one use of transport layer. Am I right? And that was providing port number, source port and destination port. What is port number? What is the length of port number? Yeah, it is 16 bits value. So range is 0 to 65535. And we have two types of port number. We divide it into two parts, well known and unknown. Well known are those port number which we have already assigned to protocol, and unknown port number are those which are free, right? So if a client machine, this machine want to access Google server. Destination port is going to be well known port number, that is 443, and source port will be what? Any random port number, it can be 1025. Why I'm saying this port number, source port number, is unknown? Because it depends on our browser, right? If I am going to access same server, Google server, from the Google Chrome, then guys my source port will be different, but destination port will be always 443. If I am accessing Google from UC browser, again destination port is going to be 443. If I am accessing Google from any other browser, destination port will be always 443. That's why this is a well-known port number. And every time source port is going to be different. Any port number from free range. Then guys, second use of transport layer is reliable and unreliable. Your communication is going to be reliable or unreliable. Transport layer is going to decide this. Right? Reliable means what? Acknowledgement. I am teaching you right now, right? And guys, again and again I am asking you, is it clear? Is it clear? Is it clear to you? Why? Just to know that whatever information I am delivering, whatever information I am sending to you, I need acknowledgement that you have received it or not, you have got it or not, right? So in the same way, let's say two device. This is PC, and then on the internet there is one Google server. So if this PC want to access this Google server, we have two options, right? Either my communication can be reliable or it can be unreliable. Like if I am sending some data from this PC to this server, if I am getting acknowledgement of that, that means it is a reliable communication. If I am not getting acknowledgement, that means it is a unreliable communication. So your communication is acknowledgement based or not, that depends on transport layer. Clear? Getting my point? So unreliable means I'm sending data without any acknowledgement. I'm not expecting acknowledgement after sending the data. But in the reliable communication, whatever data I have sent or my machine have sent, my machine expect acknowledgement for those all data. This is another use of transport layer. Then guys, your communication is going to be fast or slow. That's also depends on transport layer. So as I told you, we have two protocol here. One is TCP, most important protocol, and other one is UDP. So all this protocol, all the application layer services which are using TCP protocol, those are reliable communication. And all the services at application layer which uses UDP are unreliable communication. TCP is slow, UDP is fast. TCP is reliable, UDP is unreliable. Definitely if TCP is reliable, that means after sending the data, I will expect for acknowledgement. Right? So let's suppose two types of communication, PC1, PC2, PCA, PCB. If I am sending, I have let's say 1, 2, 3 data, right? So I am sending these 3 data to PCB without any acknowledgement. This is unreliable communication. And in the other hand, again I have 2 PC and I need to send 3 data. So I will send first data, then I will expect acknowledgement. First I will get acknowledgement, after that I will send second data, then again I will receive acknowledgement, then I will send third data, again I will get acknowledgement. So according to you, you tell me now which one is fast? Upper one, right? Scenario 1, scenario 2. Which scenario is faster communication, guys? Scenario 1, because we don't have acknowledgement here. So in UDP we don't have any acknowledgement. That's why UDP is fast as compared to TCP. Okay. So transport layer is responsible to add source port, destination port. Transport layer is responsible for reliable or unreliable communication. Transport layer is responsible for fast and slow communication. Then we have what? Network layer. Network layer is responsible to add logical address, means IP address, and data link layer. Data link layer is responsible to add physical address, means MAC address. So hope these all basic concept is clear to you. Here you can read about application layer. Application layer act as an interface between user and the actual application. This layer tells us that an application is internet based or not, right? Like guys, I have two computers and both are connected through Ethernet cable. I have one book here on computer 1 book. I want to send this book from computer A to computer B. Is internet required? Is internet required to send book from PCA to PCB? Both are directly connected with one Ethernet cable. No, internet is not required. Who will tell to PC1? Application layer. Right? If PC1 want to send a WhatsApp message to PCB, is internet required? Yes. Who will tell to PC1? Application layer. Then there are various services like web service, file service, remote access service, time service, mail service, etc. at this layer. Right? So we have multiple services at application layer, and these services can be accessed with the help of some protocols like HTTP, TFTP, HTTPS, Telnet, SSH, SMTP, FTP, DNS, etc. And who designed these protocols? App developers. So you don't need to learn the designing, how to design these protocols. Even you don't need to learn application layer. You only need to learn these protocols. Protocol which works at application layer. Generally in OSI model we have CML layer: application, presentation, session, transport, network, data link, and physical. Guys, on these four layer, means on lower four layers, network engineers work, and on upper three layer, software engineers work, right? Like software developer, software tester, who design the application, who design the software, those guys work on these three layer, and network engineers work on lower four layer like transport, network, data link, and physical. Okay, so web service means getting web page. File service means sending file from one device to another. Remote access service means, let's suppose in your company guys, there are multiple router 1, router 2, router 3, there are multiple switches, right? And multiple end devices are there, as well as multiple firewalls are there, like this: F1, F2, F3, right? And you are the network engineer of this company. You are the network engineer of this company, and you are sitting in, let's say, Delhi office, right? And like Delhi office, you have multiple office, like let's say in Mumbai also, in Bangalore also, in Chennai also. So at each branch you have multiple networking devices, and as you are network engineer, how you are going to monitor the network? Whenever problem will comes, how you are going to troubleshoot? So actually you will use remote access service. You will enable remote access service on all networking devices, and with the help of remote access service you can access all devices from a centralized location, right? So let's say this is your PC connected with any device with this switch. This is your PC, you are connected with this switch, that means you are connected with network. Now requirement is there should be again IP reachability, means you should be able to, your machine should be able to ping all networking devices. devices at Mumbai location, devices at Bangalore location, right? So if there is IP reachability, then you can access any devices from this PC. That is what remote access. I can access devices remotely. So this is remote access service. And to use this service, I have two protocols, Telnet and SSH. So if someone will ask you what is Telnet or what is SSH, so it is an application layer protocol which is used to access remote service, right? Or in other word, you can say Telnet is an application layer protocol which is used to take remote access of networking devices, which is used to take remote access of networking devices. Is it clear? So you need to learn these all protocol, guys. HTTP, TFTP, HTTPS, Telnet, SSH, SNMP, TFTP, DNS, and few more like POP3, SMTP, then presentation layer. So at this layer, data is presented in a standard format. The data can encrypted, decrypted, compression, decompression at this layer. Like ABCD can 1 to 3 can be encrypted into ABC, and again at the receiver machine ABC can be decrypted into 1 to 3. Then session layer create, maintain and terminate session. In last class we talked about the sessions, like what is the importance of session, why session layer is important. Whenever a reply will come from a server, right, session layer is the only real who will put the reply in the correct browser, in the correct tab. So it keep data different sessions separate. Then guys, we have what port number. So port number is 16 bits value represented in decimal, range is 0 to 65535. Port number is a unique ID of the protocol in computer networking. So whatever protocol you have at application layer, how we are going to identify that protocol? With the help of port number. So each protocol at application layer will have one protocol number. And guys, as a network engineer, you have to remember some port number and protocol, like what is the port number of HTTPS, what is the port number of Telnet. It will help you to configure network policies. When we'll see the configuration, advanced configuration of these protocol, that time we will use the port number of a protocol. So I have on computer and then server. On this server, guys, two services are running, 443 and 21. 443 means HTTPS, 21 means FTP, right? So when this server will receive any type of packet from the computer, at layer 1 this server is going to check destination MAC. At layer 3 the server is going to check destination IP. At layer 4 server is going to check what? Destination port. And on the basis of destination port, the server will decide I need to hand over actual information to whom, to which protocol. So if destination port is 443, then it will hand over actual data to HTTP protocol. If destination port is 21, then it will hand over actual data to FTP. So at application layer, both protocol is running, HTTPS as well as FTP, right? And transport layer will hand over data to this protocol, to HTTPS or to FTP on the basis of destination port number. So now you have some protocols, some important protocols with port number. You can see FTP port number is 20 and 21. It uses which protocol at transport layer? TCP. Then SSH. SSH port number is 21. Telnet port number is 23. SMTP port number is 25. DHCP port number is 67, 68. POP3 port number 110. NTP port number 123. HTTP port number 80. Right? So each application layer protocol will have one port number, and you can see guys, these all port number, these all port numbers belongs to well known port number, yes or no, from this range 0 to 1024. And then you have unknown port number, this range. This is free, these are free port number, so a sender device or client machine can use this port number as a source port number. Because if I want to send a data to Google server, source can be anything. Source can be Google browser, source can be Mozilla Fire, source can be UC browser. Then guys, very important layers of OSI model, that is transport layer. So this layer provide reliable or unreliable delivery, perform error correction before transmit. Two protocols are work on this layer, that is TCP and UDP. One more very important work of transport layer is dividing large data into a smaller part. Try to understand one scenario guys. Here let's suppose I have a network like this. I have one router, then I have one switch here, again here I have one switch, then here I have one server, and here I have one PC. R1, switch 1, switch 2, PC1, and server. Done. IP address of PC1 is 10.1.1.1/24. IP address of server is 20.1.1.1/24. This is your F0/0, fast Ethernet 0/0, and this one is fast Ethernet 0/1. Now try to understand MTU. MTU stands for maximum transfer unit. Maximum transfer unit means what? Capacity of a port to transfer data, size of data, maximum size of data. Capacity of a port to send maximum size of data is known as what? MTU. That's why we are saying it is maximum transfer unit. So let's suppose MTU of this interface is 1500 byte, and MTU of this interface is also guys, let's say 1000 bytes. 1000 bytes. It means what? Router 1 can receive any size of data on fast Ethernet 0/0, but it cannot send data whose size is more than 1500 byte from 0/1. Because MTU of fast Ethernet 0/1 is 1500 byte. That means maximum transfer unit of this interface is 1500 byte. Means this interface can transfer maximum up to 1500 byte data. This interface can transmit up to 1500 byte of data. So if this router will receive a data whose size is, let's say, 2000 byte, then what will happen guys? Router is going to drop it. Router is going to drop it. See, again we have option. I can tell to router that please divide it into two parts and then forward to switch number 2. But by default router will drop it. By default router is going to drop it because their MTU of exit interface is 1500 byte, and this router need to send a data whose length is 2000 byte. So it is not possible to send 2000 byte of data from a interface whose MTU is 1500 byte, whose MTU is less than 2000 byte, right? So what will happen if this PC will generate a data whose size is 2000 byte for server 1? Router is going to drop it, yes or no? Will router forward this data? No. PC1 will forward it to switch 1 will forward it to router 1, and router 1 is going to drop it. Router 1 can accept this data because MTU of this interface is 1000 byte. But MTU means what? Maximum transfer unit. That means it can receive any size of data, right? But while exiting data from 0/1, it will drop the data because exit interface MTU is 1500 byte and data length is 2000 byte. So on PC number 1, transport layer is going to divide this data according to MTU. So see, try to understand another function of transport layer, right? When PC1 will try to send data to the server, first transport layer is going to check MTU. MTU of all devices between source and destination, right? And it will elect minimum MTU. It will elect minimum MTU. So minimum MTU is 1000 byte. Now according to the minimum MTU, your PC is going to divide large size of data into a smaller part of data. That is known as fragmentation. That is known as fragmentation. So fragmentation is dividing large size of data into a smaller part. Dividing large size of data into a smaller part. And which layer is responsible for this? Transport layer, right? Transport layer. So before adding source port and destination port, transport layer will divide the data into a smaller part based on MTU. Based on MTU. So if minimum MTU between source and destination is 1000 byte, then data size should be 960 byte. Why I have subtract 20 byte? Because see, when transport layer will add extra information, means source port, destination port, that means transport layer is adding header, and definitely there will be some size of that header, right? In the same way, when network layer will add source IP, destination IP, it will add header, and that header will consume some length, size. That header will have some size. So guys, transport layer is going to add 20 byte extra information. 20 bytes extra information. And network layer is also going to add 20 bytes extra information. So that's why I have subtract 40 bytes from the MTU. So after adding transport layer header and network layer header, my length of data is going to be 1000 byte. Okay. So dividing large size of data into a smaller part is known as fragmentation, and transport layer is responsible to perform fragmentation on the basis of MTU. Now if you are thinking how transport layer is going to find minimum MTU, so don't worry, we will discuss it. We will see how transport layer is going to find minimum MTU. Is it clear? Yeah. Okay, a very good question. What about layer 2 header? Because layer 2 is also going to add source MAC and destination MAC. Correct. What about layer 2? Layer 2 is also going to add source MAC and destination MAC. Anyone who can answer to this question? Is there anyone who can answer to this question? See, data link layer means MAC address is responsible for node to node communication, right? That means when PC will forward traffic to switch will forward to router. When router will receive traffic on this interface, it will remove layer 2 header. Getting my point? It will remove layer 2 header. And when again router 1 will forward it from this interface, it will add layer 2 header, right? So actually guys, this device router is going to add layer 2 header on port on the interface, right? So right now I am talking about layer 3 MTU. This is layer 3 MTU. Layer 3, na brother. I have included the header of network layer also. I have included the header of transport layer also. Right. So each node is going to remove layer 2 header and it will add new layer 2 header on their port. So that's why we didn't consider any length for layer 2 header. Done. Clear? Any other question? Okay. So transport layer is responsible for reliable and unreliable communication, for error detection before transmission. Two protocols work at this layer, TCP and UDP. TCP stands for Transmission Control Protocol and UDP stands for User Datagram Protocol. TCP is a connection oriented protocol and UDP is a connection less protocol. Now try to understand the meaning of connection oriented and connection less. Connection oriented means before sending the actual data, I will establish a connection with receiver device. Like guys, PC1 need to send one data to this server. PC1 need to send one data to server. So PC1 have two options. Either it can send data directly to server, or before sending the data, it can establish a connection with server. Let's say I am sending data to server, but server is very busy. There is no space in the buffer memory on the server. So what server will do? Server will discard the data, correct? So PC1 is sending data to server, but server is discarding the data. Because let's say this server have capacity to handle 100 number of user at a time. And already 100 number of user are accessing the server, have already access to this server. So this client will send data to server, but server is going to discard it. So that's why we have what another option. Before sending the data, we will establish a connection. We will inform to server that brother, I am going to send you data. Please be ready. Before sending the actual data, I am going to inform to server, brother, I am going to send the data, send to your data. So be prepared yourself, right? So server will keep some memory for PC1, right? Because server have no knowledge that I am going to receive some data from PC1. So there will be one logical connection, guys, between source and destination. There will be one logical connection, right? So like, let's say I am teaching you right now and I am in this room and my brother is sitting in next room, next to this room, and I need a glass of water. So I can say, hey brother, please give me a water, please give me a glass of water, right? Tell me, am I sure guys that my brother is coming with a glass of water or not? No, because I don't know my brother have listened me or not, my brother have received my information or not. So my actual information is, please give me a glass of water. So I am not going to send actual information directly like this. First I will call to my brother, hey brother, then he will say hello, right? Now this is what one connection. Now I know, okay, my brother is listening me, correct? Now I am going to say, please give me a glass of water. This time I am 100% sure my brother will come with a glass of water, correct? So in the same way, before sending actual data, PC is going to establish a logical connection with server. The meaning of this connection is, I am going to send you some data. Be prepared yourself, right? Otherwise, if PC will send data directly to the server, there is no any guarantee that server is going to receive, accept it, or server is going to reply him. There is no guarantee. But if we have one logical connection guys between source and destination, then there is guarantee of data. Got it? So TCP is a connection oriented protocol and UDP is a connection less protocol. So if you are going to send some data from PC1 to server by using TCP service, by using TCP protocol, then it is going to be reliable, means you will get acknowledgement of each data, and before sending the data it is going to establish a logical connection. But again I am going to send one data with the help of UDP by using UDP protocol, then guys there is no any connection, there is no any acknowledgement, directly I am going to send data to server, there is no any guarantee that server is going to accept it or not, right? So as we have connection in TCP, as we have acknowledgement in TCP, TCP is slow protocol, and we don't have any acknowledgement, we don't have any connection here, that's why UDP is an fast communication, right? So tell me the real time scenario, which protocol you will use, TCP or UDP? No, totally depends on our requirement. If I need a reliable communication, like guys, my website pmnetworking.in, my website, right? So what I want, that whenever a user from internet will access my website, there should be reliability, right? There should be reliability. Okay, if communication is slow, that is okay, maybe it will take some time, 2 seconds, 3 seconds, 5 seconds to reload the site, to get access of my web page, but this is reliable, then I will use TCP. But just assume video conference, if I am calling you through WhatsApp video call, then guys my communication should be fast, right? Like we are connected through Google Meet video conference, right? So here we need fast communication because it is bidirectional, we are communicating. So whenever we need a fast communication, I will use UDP. Whenever I need a reliable communication, I will use UDP. So both are in use, TCP as well as UDP. All video conference or fast chat, those are using UDP, and all reliable protocol like application access or web page, these are guys based on TCP. Done. So in OSI model, application layer clear, presentation session layer clear, port number is also clear. Each protocol at application layer have one unique protocol number. With the help of that port number, with the help of that port number we identify the protocol. Like HTTPS have a unique port number, that is 443. FTP have one unique port number, that is 21. So you can take a screenshot of these port number and protocol because these are important. We have two types of port number, well known, unknown. Okay, these are clear. Now, transport layer. Transport layer is going to decide reliable or unreliable delivery. Before sending the data, it is going to perform error correction. Then two protocols work at this layer, TCP and UDP. Now you know the basic difference between TCP and UDP. First difference, TCP stands for Transmission Control Protocol, UDP stands for User Datagram Protocol. First difference, TCP is slow, UDP is fast. In TCP, we have reliable communication, we have acknowledgement. In UDP, we don't have any acknowledgement. In TCP, before sending the actual data, my sender machine is going to establish a connection with receiver machine. But in UDP, my sender machine is going to send data directly. Done? So see some difference between TCP and UDP. First difference, TCP is a connection oriented, UDP is a connectionless. You know the meaning of connection oriented, right? Is it clear? Connection oriented and connectionless. Is it clear, guys? The meaning of connection oriented and connectionless. Connection oriented means we have a logical connection between source and destination. We establish a logical connection before sending actual data, right? And connectionless means I'm sending data without any connection. Then in TCP, we can arrange the receiving traffic in sequence. As I told you, transport layer is responsible to divide large size of data into a smaller part of data based on MTU, maximum transfer unit. So let's suppose a sender machine, this machine have one data and the length of data is, guys, length of data is 10,000 byte. Okay, bytes. So transport layer need to divide this large size of data into a smaller part. Yes or no? So it will divide it in how many part? Into multiple part, like data 1, data 2, data 3, right? And always keep in mind one thing, that the actual information at application layer is called as data. What we call to actual information? Data. Like my machine is generating one HTTP traffic, so I can say it is a HTTP data. At presentation layer also we are going to call information to data. At session layer also we are going to call data. But at transport layer, after dividing large data into a smaller part, transport layer is going to add transport layer header. Transport layer header. And inside the transport layer header, what will be information? Source port, destination port. And now guys, we are going to call it segment. We are going to call it segment. So segment means what? If someone will ask you what is segment, segment means a small part of data with transport layer header, right? So let's say here on PC number 1 I have multiple segments, segment 1, segment 2, segment 3 and segment 4, right? After that PC1 is going to send this segment to server. Let's say due to congestion between source and destination, or because of congestion on this link, server have received segment number 4 first, then it have received segment number 3, then segment number 1, and then segment number 2. How the server machine can rearrange it, and server machine need to rearrange it, right? Again at transport layer on the server, it is going to combine all a smaller part of data into single data. So at the receiver machine, transport layer have to again combine all a smaller part of data into a single data. So how transport layer is going to arrange it? So before sending this segment, sender machine is going to perform sequencing over here. What? Sequencing. Means it will add one sequence number 1, sequence number 2, sequence number 3, and sequence number 4. So on this segment, what will be sequence number 4? On this segment, what will be sequence number 3? Here 1, here 2. So with the help of sequence number, receiver machine can rearrange these sequence, right? If there is no sequence number, then guys, suppose my actual data is hello, how are you, right? So in segment 1, information is hello. In segment 2, information is how. In segment 3, information is are. In segment 4, information is you, right? So if there is no sequence number, then receiver machine at transport layer, on receiver machine at transport layer, your data is going to be you, then are, then segment number first hello, and then how. This is your data. You are hello how, correct? So sequencing is also important. So with the help of sequencing, with the help of sequence number, receiver machine can rearrange the received data. Clear? Yes, transport layer, correct. So whenever transport layer is going to divide a large size of data into a smaller part, right, it is going to perform sequencing. It will add sequence number to each segment, then it will add header. Actually in the header only there will be sequence number. Inside the header there will be sequence number also, right? So guys, means, yeah, then only we will have sequence number. Yes, in UDP does not use sequencing. So that's why in UDP, receiver machine cannot rearrange the data, right? And even in case of UDP, because of congestion, let's say receiver machine have received only 3 segment, right? It have not received one segment. Let's say one segment has dropped on the link between source and destination over the network. So guys, sender machine will never get to know that receiver machine have not received one segment, right? So while video conference, let's say because of bad internet, if you are not able to listen me, that means some information is missed on the network, over the network. So my machine is not going to retransmit it. The reason, this communication is UDP based. Clear? Video conferencing is UDP based. This is why you are not going to receive the missed information or dropped information, because my sender machine is never knows which data receiver machine have received or not. Sender machine does not have any track of data in case of UDP. We don't have sequencing in case of UDP. 1 minute. Okay, clear guys? Any question? Yes, go ahead. Sender machine will not get acknowledgement for that now. See, when receiver machine will receive the segment, it will send acknowledgement. So if sender machine will not get acknowledgement for, let's say, segment number 3, right, then sender machine will retransmit it. Then sender machine will retransmit it. Let's say I am teaching you. After the explaining, I will ask you, is it clear to you? If you will not speak, if you will not give me acknowledgement, then I will again teach you same thing. Like that. Okay. So data retransmission can be done in case of TCP, but data retransmission can't be done in case of UDP. So while video conference, whatever information you have not received because of bad internet connectivity, you are not going to receive it again. So this is what? Unreliable. This is unreliable. So that's why I told you guys, like my website. So I will never want that whenever someone is trying to access web page, it will get half page only, or some information is not showing because of bad internet connectivity. So that's why website application should be based on TCP. And whenever I need fast communication, right, we don't need reliable communication. If I will go for reliable, guys, through video conference, while communicating through video conference, it is going to be very slow. It is going to be very slow, because for each and every segment, receiver machine is going to send acknowledgement. Okay. So both are in use. TCP and UDP depends on our requirement. Got it? Can I move? So TCP is connection oriented, UDP is connectionless. In the TCP, we can rearrange the receiving traffic in a sequence, but in UDP we cannot arrange receiving traffic in sequence. Data retransmission can be done in TCP, but data retransmission can't be done in case of UDP. TCP is a reliable protocol, UDP is a unreliable protocol. Reliable means acknowledgement, means we have acknowledgement here. In UDP we don't have any acknowledgement, it is unreliable. Then guys, flow control can be achieved in TCP, flow control can't be achieved in case of UDP. Then windowing is used in TCP, windowing is not used in case of UDP. Four-way handshake is done in case of TCP, four-way handshake is not done in case of UDP. These are differences between TCP and UDP. TCP is slow, UDP is fast. Default header length of TCP is 20 byte, default header length of UDP is 8 bytes. So these two are benefit of UDP, like header length is only 8 bytes here, and it is fast as compared to TCP. TCP is going to add 20 bytes extra information with data, but UDP is going to add only 8 bytes extra information. Clear? Then HTTP, HTTPS, Telnet, SSH, these protocol used TCP at layer 4, and DHCP, NTP, DNS, these protocols use UDP at transport layer. Okay, so you can find 10 application layer protocol for TCP, 10 number of protocol for UDP. Segmentation can done in case of TCP, but segmentation cannot be done in case of UDP. So UDP is not going to divide large size of data into a smaller part of data. So in case of UDP, guys, in this scenario, if my communication between PC1 and server is UDP based, then I have to configure router in such a way so that router can divide large size of data into a smaller part. Otherwise router is going to drop it, right? So for UDP communication I have to configure a router so that router can divide large size of data into a smaller part of data. Or for the data at layer 3, let's say this PC is generating any data at layer 3. At layer 3 means at network layer. So again, if data at network layer, if PC is generating a data at network layer whose length is 2000 byte. So guys, now we don't have transport layer here because network layer is going to hand over it to data link layer will hand over it to physical layer. So he is going to divide this data router. So for UDP based traffic or for any traffic below transport layer, I have to configure router, right, to divide large data into a smaller part. And when router is going to divide large data into a smaller part, that is called segmentation. Segmentation. So what is the difference between segmentation and fragmentation? Segmentation and fragmentation. Very good. What happened? I'm not able to accept his request. फोर वे भी डिस्कस कर लेंगे थोड़ी देर में. Okay, so for all the traffic at layer 3, layer 2 or UDP based traffic, you have to configure router to divide large data into a smaller part, and that is called segmentation. So segmentation. So segmentation means also dividing large data into a smaller part. Fragmentation means also dividing large data into a smaller part. But the difference is segmentation is going to be done at layer 3 and fragmentation is going to done at layer 4, right? Fragmentation will done for which type of data, guys? For TCP based data, for all application layer data which is using TCP, right? And fragmentation will done on the basis of and one more thing we can say fragmentation will done on the basis of MTU, right? Maximum transfer unit, on the basis of MTU fragmentation. And segmentation means dividing UDP data or layer 3 data or layer 2 data on the basis of, actually this is on the basis of MTU. Router is going to divide data into a smaller part on the basis of MTU, and fragmentation is going to done on the basis of MSS, maximum segment size. So as I told you, segment means, what is the meaning of segment? A smaller part of data plus transport layer header, correct? Plus transport layer header, or you can say data plus transport layer header is known as segment. So what should be the size of one segment? On the basis of that, transport layer is going to divide a large data into a smaller part, and router is going to divide data on the basis of MTU, maximum transfer unit. If router have received a data whose length is 2000 byte but their exit interface MTU is 1000 byte, so it will divide it into two parts. Yes. I think segmentation is done at layer 4 because layer 4 header is called Layer 4 header is called segments. Okay. Now connection oriented. Hope this is clear. Now three-way handshake. How a sender machine is going to establish a connection with receiver machine. Flow control. Flow control. Okay, brother, just wait for some time. I will make you understand flow control later, right? For now, you will not understand flow. Flow control means what? See, I am sending some data to receiver machine, right? If some data is missed on network, over the network, so I will retransmit it. That means I have control on flow, yes or no? But in case of UDP, we don't have any sequencing, you don't have any acknowledgement, so we don't have flow control, right? We don't have control on flow. If any data is missed, we don't know about that. Then guys, three-way handshake means how a sender machine is going to establish a connection, logical connection with receiver machine. So actually sender machine is going to send one data, that is SYN. Now what is SYN? SYN is a message, not message, actually this is a TCP header, transport layer header. So sender machine will send one TCP header with SYN bit on. In TCP header we have multiple bits. We will discuss about the bits later. Right, out of those bits guys, I have one SYN bit. SYN means synchronization bit. So sender machine will on synchronization bit in the TCP header. After that it will send it to receiver machine. So destination IP will be the IP address of receiver machine. Destination port will be the port number of service which I am going to use. And once receiver machine will receive SYN bit on header, TCP header. Generally we call this a SYN message. SYN message means TCP headers with SYN bit on. TCP header with SYN bit on. When receiver machine will receive TCP header with SYN bit on, means whenever a receiver machine will receive a SYN message, it will get to know that someone is trying to establish a connection with me. SYN means hello. Sender machine is sending hello to receiver machine. Then receiver machine will reply to sender machine with SYN bit on. Means receiver machine is also saying hello and acknowledgement. I get your hello. I get your hello. So receiver machine is sending again TCP header with two bits on. SYN bit is also on and ACK bit is also on. Acknowledgement bit is also on. So on sender machine will receive SYN plus ACK message. It will get to know, okay, receiver machine have received my SYN message and he is sending their on SYN message. So sender machine is now going to finally acknowledge him. And this is how connection will establish. Okay, so first sender machine is going to say hello, then receiver machine is going to say hello and I receive your hello. Then sender machine is also going to say I receive your hello. This is how both machine is going to establish a connection. And after this connection, sender machine is going to transfer actual data. Okay. Then guys, sequencing. In TCP, sequencing is done with the help of sequence number, so that receiving device can arrange the segment in original order. Then we have MTU. Sequence number, again sequence number is 16 bits value represented in decimal. Sorry, it is 32 bits value represented in decimal. So range can be 0 to 2 to the power 32. Then MTU. Before sending data, the sender device negotiate MTU of all devices between sender and receiver. Choose minimum MTU to transfer data, right? So like my data is hello, how are you? So sequence number is going to be 1, 2, 3, 4, right? So let's say receiver machine have received hello first, then are, then you, then how. So it can rearrange it because see each segment have one sequence number, right? So by the help of sequence number, receiver machine will arrange this data in original format. And if guys sender machine have sent these 4 segment but receiver machine have received only these 3 segment, then receiver machine is not going to acknowledge for segment number 4. So sender machine will retransmit this segment. Okay. TCP is a reliable protocol. Here see the flow control. Losing a data can be tragic. So we need safe solution in place is known as flow control. The segment delivered are acknowledged back to the sender upon their reception, right? So after receiving each data, receiver machine is going to send the acknowledgement, that is flow control. Any segment not acknowledged are retransmitted, right? But if receiver will send acknowledgement after every segment, then communication is going to be very slow. Like if sender machine is sending 5,000 number of segment, so if receiver machine will send acknowledgement after each segment guys, then definitely communication is going to be very slow. So that's why we come up with a technique called windowing. Like we divide IPv4 address into classes to reduce the wastage. So this is one kind of technique to reduce the shortage, right? In the same way, to make TCP more faster, we come up with windowing technique. So what will happen in windowing? While three-way handshake, while establishing a connection between source and destination, both machine is going to negotiate their buffer memory. Actually, receiver machine is going to share their buffer memory. Let's say their buffer memory size is 5,000 bytes, right? So it is going to tell to sender machine while three-way handshake with the help of SYN message or SYN plus ACK message, both machine is going to negotiate their buffer memory. And on the basis of buffer memory, both machine is going to decide one window size, right? So receiver machine can store 5,000 byte of data in their buffer memory, right? So let's suppose window size is 5,000 bytes. Getting my point, guys? Now what will happen? After receiving 5,000 byte of information, receiver machine is going to send acknowledgement. Getting my point? After receiving 5,000 bytes of data, it will send acknowledgement. So let's say size of one segment is 1,000 bytes. So after receiving 5 segment, receiver machine will give acknowledgement. This is how windowing work. So in windowing, so in windowing, both the devices will negotiate their buffer memory. The device will elect least buffer memory as window size. A sender will send data equivalent to window size and then expect acknowledgement. With the help of windowing, we also achieve flow control, and windowing is used to reduce number of acknowledgement. So earlier receiver machine was sending acknowledgement after each segment. Now receiver machine is sending acknowledgement after window size. So why we come up with windowing technique? To reduce the number of acknowledgement, or you can say to make TCP more faster, right? So like you can see, buffer size of this server is 700 byte, and MTU of this interface, this device is 100 bytes. Means this device can send up to 100 bytes data, right? So one segment can have 100 bytes of data. So first it will send 100 byte of data. It will not expect for acknowledgement. It will send second data, third data, fourth, fifth segment, sixth segment, seventh segment. Now it have sent 700 bytes of data. So now client machine will expect acknowledgement. Client machine will expect now acknowledgement. So receiver machine will send acknowledgement. After that again sender machine is going to send next segments. Again it will send 7 segments and expect acknowledgement. So you can see here, for 7 segment there is only one acknowledgement. Without windowing, for 7 segment there was 7 acknowledgement. And 4-way handshake, like 3-way handshake is used to establish a connection, logical connection between source and destination. In the same way guys, 4-way handshake is used to terminate the connection. 4-way handshake is used to terminate the connection. It is used to terminate the connection. Let's say sender machine and receiver machine have established a connection to send some data. But what after sending all data, they have to terminate the connection as well, right? Because server will have, the server is not like it can maintain any number of connection on the basis of hardware, memory, operating system, CPU. It depends how many connections server can maintain at a time, right? So after sending all the data, client machine have to terminate the connection. So that's why we have what guys, 4-way handshake. After sending complete data, sender machine is going to on fin bit. Sender machine is going to on fin bit. Fin means finish bit. And once receiver machine will receive fin bit, it is going to give acknowledgement. And then receiver machine will also send finish bit on TCP header. Again sender machine is going to acknowledge him. So here I have 4 messages. So that's why we said it is a 4-way handshake. Both machine is going to inform each other that data transfer is finished. Then we have what? Network layer. Yes. Go ahead, brother. Okay. No, while three-way handshake. While three-way handshake will negotiate the buffer size. No, sender machine and receiver machine both are going to share their buffer memory in the SYN message. SYN is what? TCP header. In the TCP header, I am going to on SYN bit and I will send my buffer memory size. That my buffer memory size is, let's say, 100 byte. So while three-way handshake, both machines are going to negotiate their buffer memory. Then you have network layer. So network layer, provide logical address. Router layer 3 switch works at this layer. The main function of router works at this layer. The main function of the router works at this layer. The protocol used at this layer is, guys, IP, means IPv4, IPv6, EIGRP, OSPF, ICMP, and many more protocol are there. Then I have data link layer. So data link layer is responsible for physical address. At this layer, error detection is done. Right, so data link layer is responsible for error detection as well. If there is some modification in data, let's say a sender machine have sent some data to receiver machine, and guys, someone on the link have modified the data, so this receiver machine can detect that modification. Right, if there is some error in the data, receiver machine can detect it. At which layer? A data link layer. Even at transport layer also have capability to detect error. So it perform, both layer perform error detection. And switch bridge works at this layer. At this layer is responsible for forwarding data from one device to another device in a network. This is the only layer in which header as well as trailer is added. We will discuss. Protocol used at this layer is ARP, HDLC, ARPA. ARPA is responsible to add source MAC, destination MAC, and etc. Now guys, tell me, telnet. Telnet is a protocol which uses which service at transport layer, or which protocol at transport layer, TCP or UDP? Physical. Telnet, yes. Telnet is a TCP based protocol, right? Here also you can see Telnet 23 TCP. Done. And physical layer? Done. Trace route. There is another mechanism, brother. Trace route is UDP based. UDP based. And guys, physical layer like hub, repeater, access point, media, and this layer convert data into bits. Then PDU. PDU means protocol data unit, means form of data at a layer. On a particular layer, what is the form of data? So as I told you, at application layer, we call data to data. At presentation layer also, at session layer also, but at transport layer, what we call to data? Segment. So segment means what? Segment means data plus transport layer header. Packet means what, guys? Segment plus network layer header. And frame means packet plus data link layer header. Done. Transport layer source port, destination port. Source port, destination port. Source IP, destination IP. Source MAC, destination MAC. Packet means segment plus network layer header now. Right. Yes. Actual information is this one. Data at physical layer. Then guys, encapsulation and decapsulation. So now tell me, there is one client machine, this machine, and there is one router, R1. On this router, let's say telnet service is enabled, right? So telnet uses port number 20 3, right? So port number 23 is enabled. IP address of router is 10.1.1.1. IP address of this client machine is 10.1.1.2. MAC address of PC is A, MAC address of router interface is B. Now when I will run command telnet and the IP address of router 10.1.1.1. So which layer protocol it is? It is an application layer protocol. Means telnet is going to generate their data at which layer? At transport layer. Sorry, at application layer. It is an application layer protocol. So telnet will generate one data at which layer? Application. Then it will hand over to presentation session, after that transport. Now transport layer is going to add source port, destination port. So tell me what will be source port number? Any random port number? 1025. Destination port will be 23, well known port number of telnet. Then guys, source IP 10.1.1.2. Destination IP 10.1.1.1. Source MAC, destination MAC, right? This is your data. This is what segment. This is what packet. And this is what frame, right? So adding extra information with actual data is encapsulation, right? And when router will receive this data, router is going to first remove this header, then it will remove this header, then it will remove this header, and after that it will hand over actual data to telnet protocol. Yes or no? If telnet service is not enabled over here, then tell me which protocol is going to drop the data. Which protocol will drop the data, or at which layer data get dropped on the router, guys? If telnet is disabled, but yeah, transport, right? How network, brother? See, layer 2 means data link layer is going to check destination MAC. Destination MAC will match, it will remove this header. Then IP protocol is going to check destination IP. If destination IP will match, then it will remove this header. Then transport layer is going to match destination port, and it will check this port is enabled over here or not. If it is enabled, then it will remove this header and hand over actual data to that protocol. If this service is not enabled, then it will discard it. Clear? So let me show you everything. And see, this is also not the complete step. This is my client machine, this is router. IP address 10.1.1.2, 10.1.1.1 telnet. So telnet is TCP based service. So first telnet protocol, once I will run command telnet and IP address of router 10.1.1.1. As telnet is a TCP based protocol, it will first establish a connection, yes or no? So this machine is going to send first SYN message, then it will send SYN plus ACK, then it will send ACK, and after that it will send telnet message, right? Because telnet traffic is my actual data in this scenario. So let me do one small lab on it. Okay. telnet. Telnet, and let's say this router is my PC. I will disable the routing on router. I am using this router as a PC. Don't worry about the configuration. IP address of PC is 10.1.1.1/24 or 10.1.1. Okay, 1 is fine. 24, and IP address of telnet server is 10.1.1.2/24. Done. Let me access both device, and let me configure the scenario first. Done. Oh, here I have configured. 2 is the IP now. PC 10.1.1.1 255.255. Done. So IP interface brief. Correct. See, IP on router is 10.1.1.2 and IP on PC is 10.1.1.1. So run interface F0/0. Submit mask is 255.255.255.0. And on guys, router also you can check. Submit mask is 255.255.255.0. Submit mask is correct. Done. Now I'm going to capture the link between router 1 and router 2 just to show you all traffic. So let me capture this link and see if I will ping to telnet, means to router, ping 10.1.1.2. My traffic will generate at which layer? Network layer, because ping is the protocol which uses ICMP protocol, and ICMP protocol work at layer 3. Which type of message it is guys? First message, ARP message. Why ARP? To resolve MAC address, right? See the name of message here, ARP. Who has 10.1.1.2 till to 10.1.1.1. So to ping telnet router from PC need MAC address of this device. So first of all, it have generated one ARP request message, and after that these are ICMP message. So if you will open any ICMP message, you can see this is my ICMP actual message, then layer 3 header, means network layer header, then layer 2 header, data link layer header, and after that guys, my frame, means my data in bits, physical layer. Okay, so here we have information of layer 3, layer 2 and layer 1, because my protocol works at layer 3. But if I will telnet, 10.1.1.2, see which type of message first it is sending? SYN message. First message is SYN message, yes or no? Then server have sent SYN plus ACK. Router have sent SYN plus ACK. And then again sender machine have sent ACK message. After that, are you able to see the actual telnet message? So before sending actual message, see, these three messages should be clear to you. Why it is sending these three messages? Because my telnet is TCP based protocol, and TCP establish a connection before sending actual data. So if you will open the SYN message, you can see you have information of layer 4 transport layer protocol, then network layer protocol, then data link layer protocol. So at transport layer, which protocol is working? Transmission control protocol, means TCP. Source port number is, guys, any random port number, and destination port number is 23, well known port number, and sequence number is 0, right? If you will open it, source port, destination port, sequence number, leave this sequence number for now, sequence number raw, and next sequence number is going to be 1, right? And see the flag, which bits is on? SYN bit. All rest bits are 0, right? Like fin bit 0, reset bit 0, push bit 0, acknowledgement bit 0, urgent bit 0, right? Rest all bits are 0. Then window size, yes, window size will be there, na brother? In, as I told you, while three-way handshake, both machines are going to negotiate their buffer memory. On the basis of buffer memory, it will decide window size, right? So it will share window side information as well here. And as I told you, these layers, means transport layer is responsible for data error detection, right? So how it is going to check error detection? With the help of checksum. Actually my data is, let's say, hello, right? So my sender machine is going to use one algorithm. Algorithm is, many times I am using algorithm. Algorithm is nothing but like your juicer. In the juicer, if you will put apple, then you will get apple juice, correct, guys? Right? If you will put orange, you will get orange juice. So actually this juicer is one algorithm to make juice. In the same way, inside the algorithm, we will have some database. Like, let's say this is an algorithm for encryption. So in the database, definitely A will have one number 1, B will have one number like 2, C will have number like 3. So if you will put A over here, you will get what? 1. If you will put B over here, you will get what? 2. Like that. Okay. So again here, both devices are going to, first sender machine is going to put the data in this algorithm, and it will find one value. It will calculate one value. Let's say value is ABC, right? If data is high, then it will get different value, different checksum value. Let's say if data is high, if I am putting high here, then I am getting what data, what output? Let's say BCD, like that. And same algorithm, this algorithm is present on receiver machine also, right? So receiver machine, when receiver machine is going to receive the data, it will also put actual data in same algorithm. So receiver machine will also get, guys, same value ABC, yes or no? And sender machine is sending this value here. You can see the checksum value, this one. So receiver machine is going to match this checksum value. If both will match, that means data is not modified. But let's suppose someone have modified the data from hello to hi. Someone have modified the data, changed the data hi. So when receiver machine will put the data in algorithm, it will get different value. That is, let's say 1, 2, 3. Then it is going to match both value. The receiving checksum value and my checksum value. Oh, both are different. That means this is not actual data. Data is modified. This is how devices is going to find error. Okay, then syn plus ACK message. And who is sending this message? 10.1.1.1 source IP, destination IP 10.1.1.2. That means PC. Then if you will open the syn plus ACK message, see who is sending? Telnet router. Source port 23, destination port, that random port number. Okay, and here guys, see the bits. How many bits are on? 2 bits. Okay, hope it's clear now. Am I audible? So these are very important to learn routing protocols or switching protocols. So make sure guys, these things, these basic concepts are getting clear to you. Then only I can teach you routing protocols. Because like when I will teach you OSPF routing protocol, so I will tell you OSPF works at layer 3. So you will get to know, okay, that means OSPF is going to generate their all message at layer 3. If telnet is a application layer protocols, means all message of telnet, it can be telnet request, telnet reply, all types of message will be generated at layer 7 at application layer. If ICMP is layer 3 protocol, that means ICMP is going to generate their all type of data at layer 3 at network layer. Okay. So receiver machine is sending syn plus ACK bit on header, and then finally sender machine is giving acknowledgement, and sequence number over here is 1. Done. So now after three-way handshake, here you can check. So TCB brief. See, we don't have any connection. See this message. Connection to 10.1.1.2 closed by foreign host. So we don't have any connection. Again, I am going to telnet. Right? Password is required, but password is not set. This is why I am not able to access router remotely. But so TCP brief. We are not able to see any connection. Let me do one thing. Let me configure one password here, or let me disable the password. Line VTY 04 say no login. Now it will not ask for password. Now I am going to say telnet 10.1.1.2. See, I have access, right? I have remote access of my router, and here I can type enable command. Again, password is not set, so go to telnet router and let me set one password. And for now on this router, if you will check TCP table, TCP brief, so you can see, brother, there is one connection with 10.1.1.1, right? And a state of this connection is established. So until and unless these users are sending telnet data, this connection will be, guys, there, right? With the help of this connection only, telnet is going to exchange their data, because telnet is a TCP based protocol, and all TCP based protocol will first establish a connection. I am talking about this connection, right? And it will maintain it in this table, TCP table, right? So this one is PC, brother. Right now I have access of telnet router, remote access router. Okay, now router. This one is router, this one is PC. Yes. By default, telnet is enabled. By default, telnet is enabled on all Cisco routers and switches. Got it? There is one command to check, by default enabled port number on router. I'm not getting that command. क्या हो गया? तो ये तो कुछ है भी नहीं। है वैसे इम्पोर्टेंट है। ऐसे होता है जैसे आप अगर कभी कभी काम किए हो ना किसी चीज़ पे, तो फिर आप ढूंढते ढूंढते उसको ढूंढ ही लोगे अगर भूल भी जाओगे कमांड तो। सो डोंट वरी। That's why it's important to perform lab of each protocol once, right? Not to remember the command, not to remember the concept, right? At least you should configure each protocol once by yourself. Done. So by default, telnet is enabled on Cisco routers. Yes, in real time also. If you are a good network engineer, you have to manually disable it. How you can disable it? Go to line VTY 04 and say no transport input telnet. Transport input telnet, say no to this command. No transport input. Like this you can disable. Okay, now you can check. So control plane host open port. Still it's showing. So run section, no, line VTY. Now on real device you can run this command, brother. Line VTY 024 no transport input telnet, this command, okay, to disable telnet. Here I am not able to run this command, right? We can try it in EvenG. When I will perform lab in EvenG, will show you. Right now this is GNS3, right? Good software for routing, right? So guys, OSI model is completed. As per CCNA syllabus. So as per CCNA syllabus, we talked about devices, IPv4 addressing, subnetting, and VLSM and OSI model. Done. Clear? Any question? So like telnet, you can use any other application layer protocol also, or you can use what we say UDP protocol also to check that in UDP is my client sending SYN message or SYN plus ACK message or not. So definitely it will not send, so you can check it, right? So to perform this kind of lab you need GNS3 and Wireshark to capture the link. Or in packet tracer, also we can see the data. Enable config T IP address, let's say config T interface F0/1 no set, and IP address, let's say 10.1.1.1 255.255.255.0. Done. Then go to PC1, and on PC1 I can configure one IP address 10.1.1.2 255.255.255.0. Done. Now I am going to use simulation mode here, and guys from PC1 I am going to say telnet and then IP address of router 10.1.1.1. So see, are you able to see two packets here? One is TCP packet and another one is telnet packet. R packet and TCP packet. Definitely first it will resolve MAC address. After that it will send TCP message, and then it will send actual telnet message. Yes or no? Right, so this is ARP message. You can open the message, then you can check the source MAC, destination MAC is broadcast or not, right? What rest informations are there. By the way, in next class we are going to discuss these all very deeply, like information inside the header, because in next class we will discuss packet flow. So this is TCP message, right? This is SYN plus ACK message, and now acknowledgement message. After that, guys, what is happening? Yes, now it will send telnet message. Here I think it is packet tracer. In packet tracer you can even filter the packet, so I think telnet packet is not showing here, right? So you can click on show all, or edit filter. No, you cannot see telnet packet here, right? You can see the OSPF, ICMP, DNS, ARP, EIGRP, DHCP, HSRP, RIP, these all protocol. Telnet is also there. Why it's not showing Telnet packet? Telnet 10.1.1.1. TCP line VTY 024. No login transport input telnet. This is the command to enable telnet, and to disable it, simply here I can say no. Now let me try. Which type of packet it is, guys? Telnet, right? So you can open it and then you can check the information. Definitely you can not read the actual telnet message, but you can read the data, header information, right? Because actual data is encrypted. This is actual data, telnet data, right? But you can check, see the TCP header. In TCP header, sequence number, acknowledgement number, window size, right? Then IP header, source IP, destination IP, checksum field is there. So we are going to discuss these all fields, guys, tomorrow in next class. Okay. In the packet flow, we'll cover headers. After that, we'll start routing. Bye, guys. That's all for today. Let's meet